How efficient is threading in Python? I heard threading is not very efficient in Python compared to other languages. Is this true? If so, how can a Python programmer overcome this?
The reason people say that multithreading is not very efficient in Python is because of the global interpreter lock. Because of the way the interpreter is written, only one thread can safely execute code in the interpreter at the same time. This means that if you have threads which are quite heavily compute-bound, that is, doing lots of stuff in the interpreter, then you effectively still only have the performance of a single threaded program. In this case, you might be better off using the multiprocessing module, which has the same interface as the multithreading module but launches multiple copies of the interpreter. The downside of this is that you will have to explicitly share memory. Where you still can reap speed gains from multithreading in Python is if you are doing something that is heavily I/O bound. While one thread is waiting for disk or network I/O, the other threads can still execute, because when threads block they release the interpreter lock.
Python uses reference counting with a cyclic garbage collector for memory management. To make this practical, it has a mechanism called the global interpreter lock, which protects the reference counting system, along with all the other interpreter internals. On a single core machine, this doesn't matter. All threading is faked via time slicing anyway. On a multiple core machine, it makes a difference. A CPU-bound Python program running on Python won't make use of all of the available cores. There are a number of possible responses to this. Use multiple processes instead of multiple threads also opens up future scalability to multiple machines, rather than different cores within a single machine. Use a Python implementation with a more multi-core friendly garbage collection mechanism, such as Jython, IronPython, or PyPy. Move the more intensive CPU operations out to C code and release the GIL while doing the calculations, thus allowing the C code to run on other cores even though only a single Python thread is active at any one time. If threads are being used to convert blocking I/O to a non-blocking operation, then that works just fine in standard Python without any special modifications. I/O operations already release the GIL.
You overcome this by using multiprocessing instead. It's as simple as multithreading in Python, but gives you the full power of all your CPU cores. Multiprocessing is a package that supports spawning processes using an API similar to the threading module. The multiprocessing package offers both local and remote concurrency, effectively sidestepping the global interpreter lock by using subprocesses instead of threads. Due to this, the multiprocessing module allows the programmer to fully leverage multiple processors on a given machine. It runs on both Unix and Windows.
One option is to use a different implementation of Python, like Jython or IronPython. That way, you still get the benefits of having the Python language without having to deal with the GIL. However, you wouldn't have the ability to use the Python-only libraries. Another option is to use different constructs than threads. For example, if you use stackless Python, tasklets are an alternative.
The threading is efficient in Python, but threads cannot run concurrently on different processors/cores. This is probably what was meant. It only affects you if you need to do shared memory concurrency. Other Python implementations does not have this problem.
If you want to support the channel, please consider liking and subscribing.